So today we'll be going through the 2021 HSC Mathematics Advanced paper. So just before we do get into it, things to note. Firstly, that this is a 3-hour exam with 10 minutes reading time. So in those 10 minutes, make sure you do go through the entire paper, read the last questions, see what's going to be trickiest for you to solve. And then if you have any extra time in that reading time, go through and start working on the multiple choice section in your head. Now, the working time of 3 hours, we have 100 marks to account for, so you should allow about 1.8 minutes per mark of each question. So, with that being said, let's dig right into it. So, question 1. So, which of the following is equivalent to sine squared of 5x? So, first thing that we should recognize is that whenever we have a sine squared x plus a cos squared x, that's always going to be equal to 1. Doesn't matter what the argument is. So here we've got an argument of 5x, as long as it's the same argument in both the sine and the cosine. So with this equation in mind, what we need to do is just solve for sine squared of 5x and simply subtract the cos squared 5x from both sides. And then we get that our answer for sine squared of 5x will be equal to 1 minus cos squared 5x, and that is option B. All right, cool. Let's keep going. Question 2. So the probability distribution table for a discrete random variable x is shown. So what is the expected value of x? Okay, so to determine the expected value, what we need to do is times the x value times by the probability of x equals x. And we want to sum those all up. So doing that, let's see what we get. So we'll have 1 times by 0.6 plus 2 times by 0.3 plus 3 times by 0.1. Okay, so let's see what we get here. So 1 times 0.6 is 0.6. So we get 0.6. And then 2 times 0.3 is again 0.6. And then 0.1 times 3 is going to be 0.3. So adding those all up, we get 1.5 as our answer there, and that leaves us with option C. Okay, now on to question 3. So which of the following represents the domain of the function f of x equals the natural logarithm of 1 minus x? Okay, so first thing that we need to note is that we have a minus x in the argument here for this function, the natural logarithm. So what do we know about the natural logarithm is that it can never have any value as an argument that is less than 0 or even equal to 0. So what does that mean here? That means that x certainly cannot be 1. So that means we can't put a 1 in there, because then it would be 1 minus 1, which would give you a math error if you put that into your calculator. So that's one quick way of working out, well, it's going to be an exclusive bracket, so the parentheses. And then we need to look at which direction will this be going. Will we be accepting positive values or negative values? So clearly, because we have a negative x, we know that we'll be taking all the way down to negative infinity. So that means now we can say, well, we can take values from negative infinity all the way up to 1, not inclusive, because if we put anything close to negative infinity in there, that makes this a positive argument, and then we'll get a value, which is perfectly fine. Okay, so that leaves us with D. Now on to question 4. So the number of downloads of a song on each of 20 consecutive days is shown in the following graph. So which of the following graphs best shows the cumulative number of downloads up to and including each day? Okay, so we've got a few different options here. The most interesting thing about the original graph that we have up the top is that it peaks very, very quickly right in the middle, and then it decreases back down. So it's a single modality graph. And so what that means we can say then is that it's going to have the sharpest increase right in the middle. So looking at all these functions, what do we have? We have a steady continual increase. We have almost an exponential increase. And then, here we are. This option here, C, that is the only option where we see a slow beginning, a quick middle, and then a slow ending. And that corresponds exactly to the original function up the top, where we have a slow start, a quick middle, and then a bit of a slowing down at the end as well. And there we are. So question 4 is going to be C. Now, question 5. So which of the following best represents the graph y equals 10 times 0.8 to the x? So first thing that we can check is going to be the y-intercept. So when x is equals 0, then 0.8 to the power of 0 will just be 1. So 10 times 1 is just going to be 1. So straight off the bat, we can get rid of options B and D. So now we're left with A and C. So now we need to look at 0.8 to the power of x. So what is going to happen to this number as x increases? So as x increases, you would start having 0.8 times 0.8 times 0.8 times 0.8, so on and so forth. And so what you can see there is that it will slowly get smaller and smaller and smaller as x increases. And so we see that our answer then must be A. So there's a typical sort of rule that follows. So if our exponential is in the form of A times B to the x, then if B is less than 1, or the absolute value of B is less than 1, then it's going to be decreasing. If x is positive, that is, of course. If x is negative, then you'll end up with sort of a double flipped exponential, and it will still be going up. Anyways, let's keep going. So now on to question 6. So there are 8 chocolates in a box. 3 have peppermint centers and 5 have caramel centers. So Kim randomly chooses a chocolate from the box and eats it. Sam then randomly chooses and eats one of the remaining chocolates. So a partially completed probability tree is shown. So what is the probability that Kim and Sam choose chocolates with different centers? Okay, fantastic. So let's just quickly fill out the rest of this probability tree, and then we should be able to work out our problem then. Okay, so let's say that Kim has already eaten a peppermint, then, well, we know that there will be 1 less peppermint and there'll be 1 less chocolate in total. However, if Kim still eats a peppermint, then if Sam is to pick a caramel, then he would have a 5 out of 7 shot at that, because again, 5 caramel remaining, but there's still going to be 7 chocolates in total. Now, if Kim initially eats a caramel, how many peppermint will we have? Well, there'll still be 3, and now it's going to be 3 out of 7. And then if it's caramel and then he also picks a caramel, then we'll have a 4 out of 7 chance of that occurring. So now again, let's reread the question. So what is the probability that Kim and Sam choose chocolates with different centers? So quickly looking at our probability tree diagram, that means we're either going peppermint, caramel, or we're going caramel, peppermint. So let's quickly work out the probability of those paths. So peppermint caramel, that would be 3 over 8 times by 5 over 7. And then caramel peppermint would be 5 over 8 times by 3 over 7. And so you see that these will actually both result in the exact same thing. And so when we compute all this, we will get an answer of 15 over 28. So we just need to add those two together. And there we are. So that's going to be option D for question 6. All right, moving on. Question 7. So the diagram shows part of y equals f of x, which has a local minimum, I should say, at x equals -2, and a local maximum at x equals 3. So which of the following shows the correct relationship between f double prime of -2, f of 0, and f prime of 3? Okay, so let's go through and see what we know. So if we have a minimum at -2, then well, we know that if this is going to be a minimum, then that means that this value must be greater than 0. Okay, so that's our first fact. The second derivative at a minimum will always be greater than 0. Let's keep going. So now f of 0, well, this one's actually pretty straightforward to see. Well, we just need to look at this point here. So that is clearly, so f of 0 is going to be less than 0. Okay, and now let's look at f prime of 3. Well, the gradient at this point is going to be horizontal, so it's clearly just going to be equal to 0. And there we are. So now if we wanted to organize these, well, we can see that this is positive, this is negative, and this is 0. So ordering those, we find that our answer for question 7 is simply going to be A, since we have a positive, then the 0, and then the negative. And there we are. Moving on to question 8. So the graph shows y equals f of x, and it asks us which of the following could be the equation of this graph. So we've got a few different equations possible down here. A few things that we should note, however, is that firstly, we have a single root over here, and then it looks like we have a triple root over here. Notice that we see a jink. That's the technical name for that occurrence when you have a triple root at a single position. So we start looking through our different possible answers, and what we see, okay, let's have a look. So if look at the first one, 1 minus x, well, that would have a 0 when x equals positive 1. So it won't be that one. So right off the bat, we know that's going to be false because it would be a single root at positive 1, and that we do not see. So we can cross out A, and we can also cross out D for that exact same reason. Now for B and C, let's look. So again, x plus 1, so that means it's going to be a single root at x equals negative 1, and that seems very feasible. That we can agree with. So it's still B and C look good. And now we see x minus 2, all to the power of 3, or 2 minus x, all to the power of 3. So the thing that we really need to decide here is the direction of this graph. So because the direction of this graph is starting from the bottom and then goes up and then continues down into the negative component, what we can then conclude is that this is going to be option C, based off of that minus x term there. Okay, so let's continue. Question 9. Let h of x equal f of g of x, where the function f of x is an odd function and the function g of x is an even function. The tangent to y equals h of x at x equals k, where k is greater than 0, has the equation y equals mx plus c. What is the equation to the tangent of y equals h of x at x equals minus k? Okay, a very terribly wordy problem. So the first thing that we need to break down is this first little section up here. So h of x equals f of g of x, where the function f of x is an odd function and the function g of x is an even function. Okay, so if you take an odd function of an even function, you'll actually end up with another even function. So the most important thing that we can note here is that h of x is going to represent an even function. And so now, it doesn't really matter, because this is all very hand-wavy, we can just kind of construct a random even equation. So let's say a parabola, for example. So now let's have a look at the rest of the question. So the tangent to y equals h of x at x equals k, where k is greater than 0, has the equation y equals mx plus c. Okay, fantastic. So let's quickly see what that might look like. So that might say, let's have k around there. So k is positive. So what would the gradient at this point look like here? It would look like something like that. And we can construct our tangent line appropriately as such. So we'd say y equals mx plus c. Okay, now as this is an even function, well, we can then clearly construct another tangent line at negative k, and this follows into the rest of the question. So over at this point here, let's see what happens here. And you'll have to forgive my drawing, but this should be approximately, a symmetric diagram. And what we see is actually they both have the exact same y-intercept. So that plus c remains the exact same. However, the one thing that does change is the gradient. So whereas initially we had a positive gradient, now we're going to have a negative gradient. And so that's how we see that our answer is going to be option B, since the only thing that changes is the gradient, and that changes into a negative value. So we can conclude that this line here is y equals minus mx plus c. Okay, let's go and finish up our multiple choice. So question 10, the line the line y equals mx is a tangent to the curve y equals cos x at the point where x equals a, as shown in the diagram. So which of the following statements is true? Okay, and then so now we have a few different values. So we have our gradient value, we have 1 over a, and we have 1 over 2 pi. So seemingly this question is very, very tricky because it really does not give you much of a direction of where to go. However, what I would recommend is to start thinking about all of this in terms of your gradients. So let's take the gradient of this straight line. Well, the gradient is clearly m. Fantastic. We've learned nothing new there. But now, what if I constructed a point at, let's say, A1? Well, that would be ever so slightly higher. That would be sitting right about there. Okay, maybe not quite that high, but it would be ever so slightly higher than that line. So what does that mean? That means that we now know something about 1 over a. That's interesting. So 1 over a, okay, so the gradient there, that means it's going to be bigger than m, because we see a steeper gradient. Ever so slightly, it will be steeper than our gradient m. And something else that we can conclude now with the same sort of idea is that if we look at exactly x equals 2 pi, well then we know that that's going to be exactly this point here, also where it's equal to 1. So we can say that then 1 over 2 pi is now going to sit exactly over here. Oops. There we are. That's a dodgy pi. Oh my goodness. There we go. Okay. And so now we know by looking at the magnitude of the gradients that we can conclude that 1 over 2 pi is less than m, which is less than 1 over a. So if I were to try and draw this up in terms of maybe a little bit more of like a magnified view, what we would see is we would see perhaps this point over here, we'd see this point over here, and we'd see this point over here. So this point corresponds to the value of a, this point corresponds to 2 pi, and so again, thinking about our gradients, well, let's just pretend it comes all the way from down here. There's the gradient, which is m. That's the gradient there. Then we have our other gradient over there, which is going to be 1 over a. And then we have, lastly, way over here, pretend that's a straight line for me, we will have the gradient of 1 over 2 pi. So that's how you can really get to know this question. It's a very tricky question, mainly because it really doesn't give you much of an idea as to where to approach this. And so we see that our only option here is going to be B. And there we are. So that's the end of the multiple choice there. So now let's get started on question 11. Okay, now on to question 11. So solve x plus x minus 1 over 2 equals 9. Okay, pretty straightforward. First things first, we just multiply everything by 2. Then we end up with 2x plus x minus 1 equals 18. Collect like terms and solve for x. We get 3x equals 19. Therefore, x equals 19 over 3. And there we are. Pretty straightforward. Okay, moving on to question 12. A right-angled triangle XYZ is cut out from a semicircle with center O. The length of the diameter XZ is 16 centimeters, and the angle YXZ is equal to 30 degrees, as shown on the diagram. So, first question, find the length of xy in centimeters, correct to 2 decimal places. Okay, so, well, let's have a think. Right-angled triangle, so we know that we can use our SOHCAHTOA. So what do we have? We have the hypotenuse, and we have this angle here, so we will be looking for the adjacent side. So that means now that we can say that, well, cos of 30 degrees is going to be equal to a over h, which is going to be equal to x, y over 16. So we can say, therefore, xy is going to be equal to 16 cos 30. And there we are. So that's pretty much that question. All we need to do now is put that into your calculator, and you get a value of 13.86 centimeters. Okay, moving on to part B. Hence, find the area of the shaded region in square centimeters, correct to 1 decimal place. Okay, so what we should do here is firstly look at the whole equation of this massive area here. So it's a semicircle. So what we should do first is say, well, the whole area is going to be equal to 1/2 times pi times the radius squared. So the radius here is going to be 8. So we'll just quickly write that in. And then we know that we're going to be subtracting the area of this triangle. Okay, so area of a triangle, well, again, we should write that now as 1/2 AB sine theta. So for A, let's say that's side length 16. And for B, let's say that's the new side length that we've just found here. However, I'm going to keep it in the form of 16 cos 30 degrees, just so that way we are more likely to get our proper exact values. And then sine of 30 degrees. Okay, and there we are. So that's all there is to this problem. You just need to chuck those into your calculator, and then we see that we'll get a value of about 45.1 centimeters squared. And that's it. Okay, moving on to question 13. So find the exact gradient of the tangent to the curve y equals x tan x at the point where x equals pi on 3. Okay, so anytime I see the word gradient to a tangent and we are working with some function, you know the first thing we're going to do is write that out. And then we're going to solve our first derivative. So here we're going to use our product rule. So just a quick reminder, that's u dash v plus uv dash, where u is x and v is going to be tan of x. So that means now our y prime is going to be equal to, x prime is just 1, so we get tan of x plus, so x, and the derivative of tan of x is sec squared x, which equivalently you can write sec squared x as 1 over cos squared x. Okay, so now we know that we're looking for the value when x equals pi on 3. So all we need to do now is just say, well, what does y prime of pi on 3, what does that equal to? Well, tan of pi on 3 plus pi on 3 times sec squared of pi on 3. Okay, and now all we need to do is start thinking about our trig identities. So tan of pi on 3, well, we know that that's just going to be equal to square root 3. Plus, and now we have pi on 3. Can't really simplify that one, unfortunately. And now sec squared pi on 3. So we know that sec squared, as I've said, can be rewritten as 1 over cos squared, I should say. And we know that cos of pi over 3 is 1 over 2. So what this ends up being is simply 2 squared. And there we are. So now for our final answer, what we should say, so the gradient, maybe we'll just say m, is going to be equal to 4/3 pi plus root 3. And there we are. So that's our answer to question 13. So just a quick application of the product rule for differentiation. Okay, moving on to question 14. So the first term of an arithmetic sequence is 5. So the sum of the first 43 terms is 2021. So what is the common difference of this sequence? So there's a few things that we know about APs. So we'll just quickly write down what we do know. So we know that AN equals A1 plus n minus 1 bracket d. Can we use that here? I don't think we can, unfortunately. So what we need to do is we need to use our other fact, and that is that the sum of the first n terms in an AP is going to be equal to n over 2 times by 2a plus n minus 1 times by d. So let's look at these terms. So a is going to be the initial term, n is the number of terms, d is the common difference, and Sn is the sum value. So looking at what we've been given, well then we know that Sn is equal to 2021. We know that there's 43 terms in this problem, so we know that n is equal to 43. We know that a is the first number, so that's going to be a 5 here, so we'll say 2 times 5. And then we can just quickly fill the rest of this out as such. So 43 minus 1, I'll just write 42, and we have d there. Okay, so what we end up doing now is just quickly solving this problem. So let's just multiply both sides by 2, and let's see what we get, and we'll probably go ahead and divide it by 43 as well. So then we'll get 10 plus 42d is equal to 94. So 94 is equal to 2021 times by 2 divided by 43. And we can say that 42d is equal to 84. Therefore, d is going to simply be equal to 2. And that's our solution there. Okay, moving on to question 15. So evaluate from -2 to 0 the integral of square root of 2x plus 4 dx. Okay, so let's quickly write this out in another form. So I'm going to write this out again as the integral from -2 to 0. But this time I'll write it in brackets of 2x plus 4 to the power of a half. So just changing it from surd to index notation. And can't forget our dx term as well. Okay, so we know how to integrate these. So all we need to do is bring down, well, what will this integrate to? This will become now a 3 over 2. So then we know that we'll divide by a 3 over 2. So then we'll know that we can have a 2 over 3. We also know that when we integrate from this middle term, well, we know that we'll then have to divide by 2. So the derivative of the inside there. Okay, and then what else do we have now? So now we just have that original bracketed term of 2x plus 4, and now all to the power of 3 over 2. And of course, this is going to be taking values from -2 to 0. And so when we do that, let's have a quick look at what we get. So, alright, so we'll get 2 over 3 times 1 over 2. Well, the 2's will cancel out, so we should just get 1/3 times by 2 times 0 is 0 plus 4. Well, that's going to be 4 to the power of 3 over 2. And then minus, again, 2's cancel out, so 1 over 3. And now minus 2 times 2 plus 4, that actually just ends up being equal to 0. So that whole thing there will just disappear. And so now all we're interested in is this 1/3 4 to the power of 3 over 2. So let's look at the square root part of that first. So the fractional 2, so then the square root of 4, I should say, is 2. And then we can take 2 to the power of 3, which gives us 8. So we see that our answer here is just going to be 8 over 3. And that's it. Okay, moving on to question 16. So for what values of x is f of x equals x squared minus 2x cubed increasing? Okay, so first thing that I think we should do anytime we see a problem like this is differentiate. So let's find our first and second derivatives. So f prime of x is going to be equal to, we'll leave it as it is. So we'll change it to 2x minus 6x squared. And then we can say that our second derivative, f double prime of x, is going to be equal to 2 minus 12x. Okay, so we know that it's going to be increasing when f prime of x is greater than 0. So what that means we should do is we should find, well, when exactly is f prime of x equals 0? Because then that will give us the two coordinates that we need to work between or from the outside regions of those 2 points. Okay, so now let's work that equation out. So we'll have 2x minus 6x squared equals 0. So now let's just move everything to the other side, so that way we can get a positive value for our leading coefficient there of the x squared. And so what we end up with is simply 6x squared minus 2x equals 0. Now we see that we can take a factor of x out, or in fact we can take out 2x. So let's go ahead and do that. So we get 2x on the outside, then we'll have 3x minus 1. So that means for this first derivative to equal 0, well, x can either equal 0 or x can be equal to 1 over 3. Okay, so now we have our 2 different points. Let's now think about, well, what does this graph actually look like of 2x minus 6x squared? That's a concave down parabola, looking like that. And we know that those 2 coordinates there of x equals 0, let's pretend that's 0, and x equals 1 over 3, those are going to be the roots of that parabola there. So what that means now is that whenever the first derivative, f of x, is greater than 0, and now we can clearly see that that's between x equals 0 and x equals 1 over 3, then that means that this original function, f of x, is increasing. Okay, so we'll say f of x is increasing for values between 0 and 1/3. I can just put it like that. And there you are. Okay, now on to question 17. For a sample of 17 inland towns in Australia, the height above sea level x in metres and the average maximum daily temperature y in degrees Celsius were recorded. So the graph shows the data as well as a regression line. The equation of the regression line is y equals 29.2 minus 0.011x. Now the correlation coefficient is r equals minus 0.494. So by using the equation of the regression line, predict the average maximum daily temperature in degrees Celsius for a town that is 540 meters above sea level, and give your answer correct to one decimal place. So all we need to do is just use this equation, but set x equals to 540. So then our value is going to be y equals 29.2 minus 0.011 times by 540. And now to one decimal place, that will give us a value of 23.3 degrees Celsius. Okay, now for part 2. The gradient of the regression line is negative 0.011. Interpret the value of this gradient in the given context. So the important thing here is that it's a very basic question, but it's actually been allotted 2 marks. So we need to be very, very specific about what this is saying. So let's interpret this gradient. So what we should say is something like this. For every meter, the height above sea level increases, the average maximum daily temperature decreased by 0.011 degrees Celsius. Whew, okay, so a bit drawn out there, but it's really important that you write every single little detail down in that sentence to get the full 2 marks. A lot of students just got 1 mark simply for saying, well, the higher above sea level, the lower the temperature. That will only get you 1 mark. You need to be very, very specific about this value and also about our x and y axes. Okay, on to part B now. So the graph shows the relationship between the latitude, x degrees south, and the average maximum daily temperature, y degrees Celsius, for the same 17 towns, as well as the regression line. So the equation of the regression line is y equals 45.6 minus 0.683x. The correlation coefficient is now r equals negative 0.897. So another inland town in Australia is 540 meters above sea level. Its latitude is 28 degrees south. So which measurement, height above sea level or latitude, would be better to use to predict this town's average maximum daily temperature, and give a reason for your answer. So the main giveaway here is going to be the correlation coefficient. So we see that for the latitude graph, we have minus 0.897. However, for the height above sea level graph, we had minus 0.494, which is significantly smaller than the new correlation coefficient. And so what that means then is that there's going to be a greater correlation between the latitude and the average maximum daily temperature. So we'll write exactly that. So what we can say now is that we will use latitude versus average max daily temp. And what we can say there is that perhaps since, well, the absolute value of this Pearson's correlation coefficient, so we'll say R, which is, we'll say R equals minus 0.897, is going to be greater than the absolute value of the Pearson's correlation coefficient for the height above sea level graph, which was R equals minus 0.494. And there we are. Don't forget to conclude with your absolute values there. And there we are. So that indicates that you know what's going on with the correlation coefficient. So a stronger correlation means that it's going to be more accurate, and a stronger correlation is going to be represented by an absolute value that's going to be closer to 1. Okay, now on to question 18. So the diagram shows a triangle ABC, where AC equals 25 centimeters, BC is 16, and angle BAC equals 28 degrees, and angle ABC is obtuse. So find the size of the obtuse angle ABC, correct to the nearest degree. Okay, so what we need to do here is, well, we recognize that we've got 2 pairs of opposite angle and side lengths that we're going to be looking for here. So what we can now use is our sine rule. So now we can say that, well, sine of angle ABC over 25 centimeters is going to be equal to sine of 28 degrees divided by 16. All we need to do now is solve this. And so doing that, we find that angle ABC is going to be equal to the sine inverse of 25 over 16 sine of 28 degrees. Okay, and so what we actually see when we do that is an angle of about 47 degrees. Now again, that's just rounding it to the nearest degree as required. However, we know that this is an obtuse angle. So what that means we need to do now is we need to quickly say, well, theta, or perhaps we should keep it as angle ABC, is going to be equal to 180 degrees minus 47 degrees. Okay, so this is all coming back from your quadrants of, I believe, all stations to central, and it's a relationship between that and our sine rule, and there's similar relationships for your cosine rule. And so what we get now is an angle for ABC of 133 degrees. And there we are. So now on to question 19. So without using calculus, sketch the graph of y equals 2 plus 1 over x plus 4, showing the asymptotes and the x and y intercepts. Okay, so a lot going on here. So we know that it's going to be a hyperbola. So let's just quickly draw up our Cartesian plane very, very broadly. And so now we know that since it's been shifted up 2, well, we know that now y can never be equal to 2. Very, very straightforward. So we can draw that asymptote in there, so we'll know y never will equal 2. Okay, so let's now have a look at our x asymptote. So we know that we now have a 1 over x plus 4. So we can never have a denominator of 0. So what does that mean? That now means that x can never equal to negative 4. So we can go ahead and draw that asymptote in there as well, like such. We can say x cannot equal negative 4. Okay, so let's quickly graph this out and see what it should look like. So it's going to be something along the lines of this, very, very roughly. So it will kind of stick to these corners there, and it will approach those asymptotes. So now we just need to quickly find out, well, where exactly will it cross these different coordinates? So our y-intercept, so again, to find our y-intercept, we set x equals 0. So then our y-int for y-intercept is going to be equal to 2 plus 1 over 0 plus 4, or 2 1/4. And then we can draw that, we'll draw that point in there a little bit more clearly. And we can just say that that's going to be 2 1/4. Okay, now for our x-intercept, we set y equals 0. So we get 0 equals 2 plus 1 over x plus 4. Okay, so this means now that this fraction here, 1 over x plus 4, must equal to negative 2. So let's just work with that. So 1 over x plus 4 equals negative 2. And so now solving for this, well, we actually get that x will have a value of about negative 4.5. So we see that our x-intercept has a value of minus 4.5. And there we go. So that's all that's required there. So we've drawn up our full hyperbola. We've indicated which directions we'll be going. We've shown that it has a y-intercept of 2 1/4 and an x-intercept of minus 4.5. And that's all we really need to write in. Okay, now on to question 20. For what values of x in the interval for 0 is less than or equal to x less than or equal to pi on 4 does the line y equals 1 intersect the graph of y equals 2 sine of 4x? Okay, so lovely trig problem here. So the first thing that we should probably recognize is that there's a different amplitude and frequency for this sine function. So an amplitude of 2 and a frequency increased 4-fold. So let's quickly draw this up and see what it looks like. Okay, so we know that it's going to look something a little bit like this. It's going to have those high amplitudes it's going to make a lot of crosses, in fact making 4 complete waves as we get to the point of x equals 2 pi. So let's just double check that. 1, 2, 3, 4. Yep, fantastic. So we've got 4 waves as we get all the way up to 2 pi. All right, so now let's draw in the line of y equals 1, and that should go about here, give or take. So it's going to be y equals 1. But of course, now we're only looking on the domain of 0 now we're only looking on the domain where x is in between 0 and pi on 4. So we know that that must occur then. Let's quickly cut this in half to find pi on 2. We can cut it in half again to find pi on 4. So now we know that we're only focused on everything to the left-hand side of this point here. And so clearly there's only 2 points where this line intersects this sinusoidal wave. And that's here and here. Okay, so we'll keep that in mind as we now solve this with a bit more of an algebraic approach. Okay, so let's get rid of that. No longer needed. All right, so we know that y must equal 1, so let's write that in. So we know that y is 1, which is also going to be equal to 2 sine 4x. Let's quickly solve for x. So we can say that, well, sine of 4x equals 1/2. Taking the inverse sine of both sides, we find that 4x is now going to be equal to, well, sine inverse of 1/2 is pi on 6. And so then simply dividing now by 4, well, we find that x equals pi over 24. So we know due to the periodicity of the sinusoidal wave and the symmetry associated with that, we know that we won't just have a solution of pi over 6, we would also have a solution for 4x equals to 5 pi over 6. And so what that means now is that x doesn't just equal pi over 24, x also equals to 5 pi over 24. And those are going to be our 2 solutions to this problem. Now, moving on to question 21. So, consider the graph of y equals f of x as shown. Sketch the graph of y equals 4f of 2x, showing the x-intercepts and the coordinates of the turning points. Okay, so let's quickly draw up our Cartesian plane off to the side here. So we know we should write in our x and y coordinate axes. Okay, so now 4f of 2x. So that means that the frequency is doubled. So that means now that the minimum here will no longer be at 4. That means it would be now at 2. Similarly, for this intercept here, it's instead of being at 6, it would now be at 3. So we know that that must now be at 3. However, we know that the y value is also being amplified by a factor of 4. So now instead of this point being at 2, negative 8, now it's going to be at the point 2, negative 32. So it's going to be way down here. Okay, and so now all we need to do is simply connect these 2 points and continue the graph as it was. And there we are. So let's quickly write in those coordinates as well. So it's going to be 2, negative 32, and 3, 0. And there we are. So that's question 21. On to question 22. So a random variable is normally distributed with mean 0 and standard deviation 1. The table gives the probability that this random variable lies between 0 and z for different values of z. So the probability values given in the table for different values of z are represented by the shaded area in the following diagram. So question A. Using the table, find the probability that a value from a random variable that is normally distributed with mean 0 and standard deviation 1 lies between 0.1 and 0.5. Okay, well for this question all we need to do is firstly, let's find those 2 different sections. So 0.5, that's over here, and 0.1, that's going to be over here. And we know that it's going to be between those 2, so all we need to do is look at these probabilities and subtract them from each other. So we get 0.1915 minus 0.0398, and that gives us a value of 0.1517. There we are. Okay, now to part B. So birth weights are normally distributed with a mean of 3,300 grams and a standard deviation of 570 grams. By first calculating a Z-score, find how many babies out of 1,000 born are expected to have a birth weight greater than 3,528 grams. Ooh, okay, so let's quickly write down what we know. So we were given the mean is 3,300. We know sigma, the standard deviation, is 570. And now we're looking at the value of x equals 3,528. So let's quickly figure out the z-score here. So remember, z-score formula is x minus mu all over sigma. And so filling that in, we get 3,528 minus 3,300, all divided by 570. And so that then leaves us with a z value of 0.4. Okay, so now let's go back to the question. It says by first calculating a z-score, so we've done that, tick. Find how many babies out of 1,000 born are expected to have a birth weight greater than that value. Okay, so greater than that value. So what that means is we're going to be looking for the area above that section. And so now to compute that, what we do is again refer back to our table. So we can see that we have for 0.4, there's going to be that probability value of 0.1554. And so what we know is that we're going to be essentially subtracting the area, all of the area left of z from 100%. So we can say that the probability is going to be equal to 1 minus 0.1554 minus 0.5, since we're now including everything left of the mean as well. So what we get then is a value of 0.3446. Okay, and now all we need to do is quickly times that by 1,000, again, because the question is asking out of 1,000 babies born, and so then we'll get a value of 344.6. Okay, so now we can conclude, and we can say that 344.6 babies are expected to weigh more than 3,528 grams. So within statistics like this in populations, this is the only time that you're ever going to be able to not round the population. So typically a question, if you're working with population, you'd always round it down because you can never have 0.6 of a person. But here in statistics, we will leave that as 0.6. So there we are. Now, on to question 23. So, speaking of population, a population P, which is initially 5,000, varies according to the formula. So P equals 5,000 B to the power of minus T over 10, where B is a positive constant and T is time in years. T is also greater than or equal to 0. So the population is 1,250 after 20 years. So find the value of T correct to one decimal place, for which the instantaneous rate of decrease is 30 people per year. Okay, this is actually a little bit of a tricky question. It starts off pretty simple, but it will get a little bit more difficult. So let's work with what we've been given. So we know that after 20 years, we have a population of 1,250. So that means we can now write that out as this formula. So b to the power of, so minus 20 over 10. We just get a minus 2 there. So now solving for b, let's quickly divide both sides by 5,000. Then we end up with a b to the negative 2 equals 1,250 over 5,000. So let's quickly simplify that. So then we'll get 1 over b squared equals essentially 1 over 4. And now all we can see then is that b squared must equal to 4. So we can say therefore b equals 2, since we know that b is a positive constant. Okay, so now we've figured out our b value. Let's quickly get rid of that, because as long as we know b, we will need a little bit more working out to get to our final value of t. And so in the actual exam, you do have about, I believe, pretty much an entire page of writing space to get this question done, as it is a little bit tricky. So b equals 2. We'll just note that down. All right, so now let's try and figure out t. So correct to one decimal place, for which the instantaneous rate of decrease is 30 people per year. So let's think about what does that mean. So we have our population is equal to 5,000 times by 2 to the power of minus t on 10. So what we're looking at now is the rate of change in the population. So that now means we're looking at dp dt. So now we need to differentiate this. So to differentiate this, fairly straightforward. All we need to do is, again, so bring down that exponential, so the coefficient associated with the t, and so we see that we have a minus 1 over 10. We're going to multiply that by the 5,000. That's already there. Now we're going to multiply that now by the natural logarithm of 2, because normally you can only bring down that indice when you have the base of e. So when you don't have the base of e, you need to make sure that you also include the natural log of that base. And now 2 to the minus t over 10. Okay, so now let's quickly see what else we know. So it's going to be a decrease of 30 people per year. So that means that dp dt must be minus 30. So now we see that minus 30 equals, so minus 1 over 10 times 5,000. Let's just write that as minus 500 times the natural logarithm of 2 times by 2 to the minus t over 10. So it's still quite a tough question to crack, but we can solve it now. So first things first, let's divide both sides by 500 ln of 2. And so I'm going to move over to the left-hand side here. And so what we get now is that 2 to the power of negative t over 10 is going to be equal to, so 30 over 500. We can simplify that. So that will end up just being 3 over 50 ln 2. And so what we recognize is that we can use our index laws to actually just flip this fraction here. So, well, it will now become 2 to the t over 10, now equal to 50 natural log of 2 over 3, simply because of our index laws there. So now if we take the natural log of 2 on the left-hand side and the natural log on the right-hand side, well, what we'll be left with is t over 10 times the natural log of 2 is equal to the natural log of 50 of the times the natural log of 2 divided by 3. Now we're going to come back over here. I'll give that a little bit of a separation. So now let's quickly solve for t. And so we see that t must now be equal to 10 over the natural log of 2 times by, now it's getting a little bit messy here, the natural log of 50 times by the natural log of 2, close bracket, over 3. Oof, and there we are. So a lot of natural logs going on here. And so what we get is that we get a value of t equals 35.3. Correct 1 decimal place. So there's a lot going on in this question. Bit tricky to follow through, but all we've done is we've used what we've been given, figured out our constant term b, then we realized that, well, the change in population must be dp dt. So we differentiate with respect to t. We get this equation down here of minus 30 equals minus 500 ln of 2 to the minus t on 10. And then we just start going through our usual steps of solving these problems. Okay, now on to question 24. So the curve y equals 3 over x minus 1 intersects the line y equals 3 over 2x at the point 2, 3. And the region bounded by the curve y equals 3 over x minus 1, the line y equals 3 halves x, and the x-axis, and the line x equals 4 is shaded in the diagram. So find the exact area of this shaded region. Okay, well, first things first, we know that it's going to be going from the origin up to this point here, 2 over 3. And what function are we following there? We're simply following the straight line function. So what we can say now is that the area is going to be equal to the integral of that straight line function, which was 3 halves x from 0 to 2. And that'll tell us the area from there to there. Alternatively, you could just figure out using the formula for the area of a triangle, but this is a little bit more fun. Plus, now we need to look at the other side of that. So now that's going to be the integral from 2 to 4 of 3 over x minus 1 dx. Okay, so let's quickly integrate those and let's see what we get. So now we get that the area is going to be equal to, well, 3/4 x squared, 2 and 0, plus we take that 3 out, and we know that there's going to be the natural log of x minus 1 on the inside there from values 2 to 4. Okay, and so what we end up with is now substituting all those in and just making sure that we're okay with those substitutions, is we'll find that we have an area equal to 3 plus 3 times the natural log of 3. And there we go. Okay, so moving on. Question 25. So a table of future value interest factors for an annuity of $1 is shown. So Simone deposits $1,000 into a savings account at the end of each year for 8 years. The interest rate for these 8 years is 0.75% per annum, compounded annually. After the 8th deposit, Simone stops making deposit but leaves the money in the savings account. The money in her savings account then earns interest at 1.25% per annum, compounded annually for a further 2 years. So find the amount of money in Simone's savings account at the end of 10 years. Ooh, okay, so again, a lot going on in this question, mainly because it is a bit of a wordy problem. So first thing that we need to do is just have a quick look at what's going on in this table. So we have the different interest rates and then the different number of periods over here. So let's quickly read back through the question. So we know it's 0.75% per annum, so we know we're going to be working in this column, and we know that it's for 8 years. So now we know that it's this row. So now we've identified the section of this table that we want to be using. So now that means that for $1,000 being invested for that value at that rate there, for that time period, we know that after 8 years, it's going to be equal to 1,000 times by 8.2132, which is simply equal to $8,213.20. Okay, so now that's after 8 years. So then we know that there's going to be some more interest accrued for the following 2 years. So let's use our compound interest formula to work that one out. So we know that A equals P times by 1 plus R over N, all to the power of NT. And then following on, let's substitute in our values now. So P is going to be the 8,213.2. 1 plus, well, now our interest rate is going to be 1.25%, so we'll write that as 0.0125, and now divided by 1, since it's compounding annually, and now to the power of 1 times 2 for the 2 years that we are counting here. So all we need to do now is chuck that into a calculator, and then we find that the amount of money in Simone's savings account at the end of 10 years is going to be equal to $8,419.81. And there we are. So that's question 25. Moving on to question 26 now. Okay, so question 26. A particle is shot vertically upwards from point 100 meters above ground level. The position of the particle, y in meters above the ground after t seconds, is given by the formula here. Now we need to find the maximum height above ground level reached by the particle. Okay, so anytime we see a problem like this where we're looking for the maximum, we always know that we'll return to our derivative. So let's find our first derivative. So we'll say that y prime is going to be equal to minus 10t plus 7t. Okay, so for our maximum, we want to set this equal to 0, so therefore 0 equals minus 10t plus 70. Now, all we simply need to do is solve for t. And so doing that, we find that t must be equal to 7. Okay, so if t equals 7, when it's at its highest point, let's now sub that value back into the original expression for y. So now we have y of 7 is going to be equal to minus 5 times by 7 squared plus 70 times by 7 plus 100. And so putting that all into a calculator, we get an answer of 345 meters. There we go. So that's part A, all done. Now for part B. It says, find the velocity of the particle in meters per second immediately before it hits the ground, leaving your answer in the form of A root B, where A and B are both integers. Okay, well, all we need to do now is solve for the time where it's going to hit the ground. So that must be where our position, y, is going to be equal to 0. So let's solve it as follows. So we know that 0 must equal minus 5t squared plus 70t plus 100. Okay, so now let's quickly solve for this problem here. So therefore, we'll rewrite it with a positive leading term. So 5t squared minus 70t minus 100 equals 0. We notice that everything is divisible by 5, so we can just go ahead and get rid of that, and we'll change that to now 14, and this will now be a 20. Okay, so now we have a simplified quadratic. Now we can simply use our quadratic equation to solve for this t value here. Okay, so now t must equal 2, so minus b plus minus square root of b squared minus 4ac all over 2, so 2a. So that will now become 14 plus minus square root of 196 plus 80 all over 2, which evaluates to give us 7 plus square root of 69. Okay, so what we need to do now is we need to take that time value for when it's about to impact the ground, and we need to then substitute that value back into our equation that we had found right at the start, because we know that this equation here, the first derivative of any function that gives us the position with respect to time, must tell us the velocity now with respect to time. And so just as a quick note as well, this must be a positive value, since if it was negative, well, we would end up with a very dodgy answer. Probably a negative time, and that isn't really going to be useful for any real life problem. So moving forward with this idea now, well, we take now y prime of 7 plus root 69, and let's see what we get. So this will now become minus 10 times by 7 plus root 69, close bracket, plus 70. Expanding those brackets, well, we see that we'll get a negative 70, and then we have that plus 70, so those will cancel out. And all that we're left with, our final velocity, is going to be equal to minus 10 root 69. And so we can then conclude that A is equal to minus 10, and B is equal to 69. And there we are. So that is now the solution in the form of A root B. Okay, fantastic. So now moving on to question 27. So our first 8-mark question. So this is going to be a little bit of a doozy, but I think we can get through it. So Kenzo has a solar-powered phone charger. Its power P can be modeled by the function P of t equals 400 sine of pi over 12t, where t is between 0 and 12. So where t is the number of hours after sunrise. So let's sketch the graph of P for t between 0 and 12. So this is just going to be the first half of our sinusoidal wave, since we know that t can go all the way up to 12. So if that was the case, we would have 12 over 12, which would cancel out, and we'd end up with sine of pi. So we know that we're going to see the first half of our sine wave, so it should look something like this. And we know that that's going to be at 12, and I should label our axes as t and p. And we know that this is going to be 400. That's our amplitude there. Okay, and that realistically is it for this graph. Now we also know that therefore the peak must come at t equals 6. So we can include that at the moment. Okay, power is the rate of charge of energy, hence the amount of energy, E units, generated by the solar-powered phone charger from t equals A to t equals B, where A is less than B, when B is less than 12, is given by the integral of P of t dt from A to B. Whew, okay, so show that E equals 4,800 over pi times by cos of A pi on 12 minus cos of B pi on 12. So there's an awful lot going on here. Let's see how we can break this down. So all we need to do is realistically just integrate this original function that we'd been given. So let's do that now. I'll just do it down here on the bottom right corner. So the integral of 400 sine of pi on 12t from A to B. Well, we can now rewrite that, and dt. We can now integrate that and rewrite that, I should say, as simply just 400 outside of 12 on pi. And don't forget, integral of sine is going to be minus cos, so we'll put a minus out the front there. Now cos of pi on 12t. Okay, and that realistically is the majority of the grunt work done for this problem here. And we know we're integrating again from a up to b. Okay, so what we have now is a pretty straightforward integration. And so let's see what we get. So now minus 12 times 400 is minus 4,800 over pi. Cos of b over 12 t, b pi, I should say, minus cos of a pi over 12. This is just going from this expansion there. Okay, and now we can absorb that negative sign out the front, and that will change our value now into 4,800 on pi. Now times by that negative, we'll just swap these around. So cos of a pi over 12 minus cos of b pi over 12. And that is as required. Okay, so now moving on to part C. To make a phone call, a phone battery needs at least 300 units of energy. Kenzo woke up 3 hours after sunrise and found that his phone battery had no units of energy. He immediately began to use his solar-powered charger to charge his phone battery. Find the least amount of time he needed to wait before he could make a phone call and give your answer correct to the nearest minute. Okay, so for something like this, we just need to refer back to our integral from earlier on. So we know that the whole energy is going to be equal to the integral of the power across the time. So that means we want 300 units of energy, and that's going to be equal to our integral of p of t dt. And now, what are our limits here? So we know that we're starting exactly 3 hours after sunrise, so we'll say that our lower limit is 3. And we don't actually know our upper limit, so we can just keep that as b for now. Okay, so let's just get a little bit more space here, and let's work this out. So we've already worked out this integral, so what we can now say is that 300 is going to be equal to 4,800 over pi times by, and now because it's going to be cos of 3, right, because a is now 3, we can simply write pi over 4. Okay, that's just coming again from, a is now 3, and 3 over 12 is just simply 1/4. And then for our other component here, minus cos of pi b over 12. So that will stay the same. Okay, so now all we need to do is simply start solving for b. So to do that, multiply both sides by pi, divide by 4,800, and let's see what we get. So after a little bit of working out, we should get that cos of pi b on 12 is equal to 1 on root 2 minus pi on 16. Let's just put some brackets around there. Okay, so all we need to do now is take the inverse cosine of both sides, and then we'll multiply by 12 and divide by pi, and we find that therefore b, so our upper integral limit, must be equal to 12 over pi, bracket 1 over root 2 minus pi on 16. And if we convert that into hours, so just chuck it into your calculator, and we see that that will give us actually a result of 3.95, okay? But now let's be really careful here, because our upper limit is 3.95 and our lower limit is 3. So that means we've spent 0.95 hours in the sun, or we can say 57 minutes in the sun required. And there we go. Okay, so now moving on to part D. So the next day, Kenzo woke up 6 hours after sunrise and again found that his phone battery had no units of energy. He immediately began to use his solar-powered charger to charge his phone battery. Would it take more time or less time or the same amount of time compared to the answer in part C to charge his phone battery in order to make a phone call? Explain your answer by referring to the graph drawn in part A. Okay, so what do we notice from our graph drawn up here? Well, we see that the peak energy, the peak power output, is going to be given right around midday. So initially, in question C, we were looking at some sort of interval from maybe here to here. And so we can see that clearly we're going to have a lot more energy given off in that peak period there. So what we can say now is that this will take less time since it peaks at 12, or maybe we should say at 6 hours after sunrise. Okay, and there we go. So that's part D. So there's a bit of a doozy of an 8-mark question there, but we've gotten through it. So all it started off with was just a simple sinusoidal graph, and then we went on to part B. All we needed to do was just simply integrate that with respect to the limits A and B. Then for part C, substituting in the value of 300 and the lower limit of 3, and then rearranging for B, and then not forgetting to make sure that we take 3.95 minus 3 for the hours represented, and then converting that now into the minutes. Okay, now on to question 28. So, the region bounded by the graph of the function f of x equals 8 minus 2x, 2 to the x, and the coordinate axis is shown. So part A, show that the exact shaded region is given by 24 minus 7 over the natural log of 2. Okay, so anytime we're looking at any sort of area of underneath a curve, we know we're going to be working with an integral. So what we need to do first is, let's quickly write down our equation. So y equals 8 minus 2 to the x. And what else do we know? Well, we know that there's going to be a y-intercept of, let's see, it's going to be 8 minus 2 to the 0, so 8 minus 1. So that point there is going to be 7. We'll just note that down. And now what about this x-intercept? Okay, let's see about that. So that means that y must be equal to 0, so we'll say 0 equals 8 minus 2 to the x. Well, we see that that only makes sense when x equals 3. So that's going to be for our x-intercept. So we know that therefore this point here is a 3. Okay, fantastic. So now all we need to do is simply integrate this function. So we'll say the integral of 8 minus 2 to the x from 0 to 3 dx. And now let's just integrate that. It is now going to be equal to, so 8x minus, so again, 2 to the x, but now dividing by the natural log of 2. Okay, so now we take our limits from 0 to 3. Let's see what we get. Okay, so first substituting a 3 in there, well, we'll get 8 times 3 equals 24. Then minus 2 to the power of 3 is going to be 8 over the natural log of 2. Okay, and now putting in our zeros, so then it would become minus 0 plus 2 to the power of 0, which is 1, and now over the natural log of 2. Okay, so we see that collecting like terms, we get a exact area of 24 minus 7 over the natural log of 2. And there we are. So that's done. Okay, part B. So a new function g of x is found by taking the graph of y equals minus f of minus x and translating it by 5 units to the right. Sketch the graph of y equals g of x, showing the x-intercept and the asymptote. Okay, so what does that mean for us now? So, simply, what our equation has changed into, so let's think about it. So it's now become x is now replaced by minus x. We've made the whole function negative, and we're also translating it 5 units to the right. So what we should do is probably say that g of x is going to be equal to, so remind ourselves, what was f of x? So 8 minus 2 to the x. So now let's take the negative of that, so we'll get 2 to the x minus 8. Okay, so that's our negative f taken care of. And now what about the negative x? So all we need to do now is replace that. So that's now negative x. And then again, translated 5 units to the right. So what that looks like now is a plus 5 to that x in the index there. Okay, so now moving on, let's just graph this function. And so first things first, we can probably tell that there's going to be an asymptote at -8. Well, y equals -8, I should say. So let's draw up our Cartesian plane. We know that there's going to be some sort of asymptote down here, and we'll say y cannot equal -8. Okay, so now let's start looking at our y-intercept and our x-intercept. So if our x value is set to 0, what are we left with? We'll now have 2 to the power of 5 minus 8. Okay, so 2 to the 5 is 32 minus 8. That gives us now a y-intercept of 24. And then we also want to find out our x-intercept. So now by setting the left-hand side to 0, we get 0 equals 2 to the minus x plus 5 minus 8. So again, we want to have 2 to the power of 3, so that way it can equal to 8. So now we know that minus x plus 5 must equal 3. And so from that, we now get a value of x of 2. And there we go. So now simply connecting these points and continuing our equation through, there we are. And that is our graph of y equals g of x. Okay, so now moving on to part C, so our final section here. So hence, find the exact value of the integral from 2 to 5 of g of x dx. Okay, so there are a couple ways to do this. I'm just going to do this the straightforward integration route. So 2 to 5 of 2 to the minus x plus 5 minus 8 dx. Okay, so that's now going to give us minus 2 over natural log of 2 to the power of minus x plus 5 minus 8x. And that's from 0 to 5. And so when you start substituting all of these in, you'll end up with a value of minus 24 plus 7 over the natural log of 2. And isn't it funny that we get that value there, whereas earlier we had a value of simply 24 minus 7 over ln of 2. So now all we've done is taken a negative of that value there. Okay, cool. Moving on to question 29. So, on the day that Megan was born, her grandfather deposited $5,000 into an account earning 3% per annum, compounded annually. On each birthday after this, her grandfather deposited $1,000 into the same account, making his final deposit on Megan's 17th birthday. That is, a total of 18 deposits were made. So we're going to say, let AN be the amount in the account on Megan's nth birthday after the deposit is made. Okay, so we need to show that A sub 3 is equal to 8,554.54. Okay, so, well, what do we know? We know that initially, A naught must be equal to 5,000. Okay, fantastic. So now let's start working out what A1, A2, A3 will be, and we'll just go down the list like that. So A1 is going to be equal to, so A0, now times by 1 plus 0.03, since we are earning an interest rate of 3% per annum. And now to the power of 1, since only 1 year has gone by. But then we know that he will then be adding another $1,000 into the account. Okay, so now that's A1 sorted. Now let's look at A2. So A2 is now going to look like this. So it's going to look like A1 times by 1 plus 0.03 plus $1,000. Okay, and now A sub 3 is now going to look like A sub 2 times by 1 plus 0.03 plus $1,000. And so you can go through and put these all into your calculator, and what we get is that for after 1 year, there should be $6,150. After 2, we'll end up with, now using that A1 value, we'll get $7,334.50. And now for A3, we get exactly $8,554.54 as required in Part A. Okay, so now part B. On her 17th birthday, just after the final deposit is made, Megan has $30,025.83 in her account. So we're not required to show that, so that's good news. Megan then decides to leave all the money in the same account, continuing to earn interest at 3% annum, compounded annually. On her 18th birthday, and on each birthday after this, Megan withdraws $2,000 from the account. So how many withdrawals of $2,000 will Megan be able to make? Okay, so for this question, we are actually going to need to use a little bit of space here. So what we want to say is we want to say let B sub n equal the amount in account after n withdrawals made. Okay, cool. So what we can say now is that, well, B naught, so the amount before any withdrawals were made, is going to be equal to $30,025.83. So that's just coming straight from the question. We know that B1 must be equal to $30,025.83 times by 1.03, because it's still increasing in interest, but now minus 2,000. Now, for B2, it's going to be following the exact same sort of path. So now we can see that it's going to be 30,025.83 times by 1.03. But now it's going to be 1.03 squared, since now it's been in there for 2 years. And now minus the 2,000 that she took out after the first year. So times that by 1.03. And then she's taking out an additional $2,000. And so what we see is we start to get a pattern to this, and so we can make a general formula for our B sub n, which will now be equal to 30,025.83 times by 1.03 to the power of n minus 2,000. And what we see going on here, 2,000 times by 1.03 minus 2,000, and you can guess that it will keep increasing in powers every single year, is that this is actually just a geometric progression, where the rate will be 1.03, and the initial amount is just going to be minus 2,000 there. So we can now write that as minus 2,000 times by 1 plus 1.03 plus 1.03 squared plus dot 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 plus 1.03 to the power of n minus 1. Okay, so now as it is a geometric progression, we can then use geometric progression formulas to kind of summarize and simplify that right-hand side there a little bit. So what we can do is we can now rewrite that as simply being equal to 2,000 times by r to the n minus 1 all over r minus 1. Okay, and we know that r is 1.03, so we can go ahead and fill that in if we would like. So 1.03 minus 1 is just going to give us 0.3, and this will become 1.03 to the power of n minus 1 subsequently. Okay, let's get a little bit more space here, so I'll move that down. So, now what are we looking for? We're looking for when she will be able to make $2,000 all the way up until the end, until she's exhausted this income and this money source. So what does that mean? We are looking for when B sub n is going to be less than 0. So when will she not be able to take out any more money because she'll have lost, or essentially lost it all by taking out $2,000 each year. So that will occur when, well, let's quickly find B sub n equals 0 first, and then we can work out B sub n less than 0. So now we can work that out. So now we'll have 0 equals to $30,025.83 times by 1.03 all to the n minus 2,000 times by 1.03 to the n minus 1 over 0.3. Okay, so what we should do here is probably add this right-hand side to the left-hand side. this right-hand term to the left-hand side, so that we're working with positive terms. And then we know that we can simply divide both sides by 2000 and times both sides by 0.03. So let's see what we get then. So now we should be working with 1.03 to the n minus 1 equals to $30,025.83 times by 1.03 to the power of n. Now times that by 0.03 over 2000. Whew, okay, so yeah, definitely a lot going on in this question. All right, so now after we've done that, well, we can see that it's getting a little bit messy, but what we can probably do is we want to try and end up with 1.03 to the n all on the same side. So what we can do now is just add 1 to both sides, and then we'll actually end up subtracting this term here across both sides. And I'll get rid of this. We'll use a bit more space later on. Okay, so doing that, what we end up with now is going to be 1.03 to the n minus $30,025.83 times by 1.03 all to the n times by 0.03 over 2000 equals 1. Okay, so now what we need to do is take out the 1.03 to the n as a common factor, and then divide across both sides by that difference that will be left over there. So then we can say 1.03 to the power of n is going to be equal to 1 over 1 minus $30,025.83 times by 0.03 over 2000. Okay, so now to figure this out, well, all we'll end up doing is taking the natural log, and so taking the natural logarithm of both sides, we now end up with n times the natural log of 1.03 is equal to, I'm just going to write the natural log of the right-hand side. Okay, so then therefore n equals the natural log of the right-hand side over the natural log of 1.03. And so what we get finally is a value of about 20.25 years. So there we are. So it does take quite a lot of working out for this problem. However, now we found that it will equal to 0 after 20.25 years. So what does that mean? That means that she will no longer be able to take out $2,000 after 20 years. So what we can say then is that therefore n equals 20 years. And that would be our final answer there. So as I said, a lot going into this question. You need to be comfortable with your sums and series and your geometric progressions, and then your index notation, and then continuing further on with your general algebra skills. So a very challenging question, and I personally think it's the longest question in the entire exam as well. Okay, now moving on to question 30. So I'm going to have to do a little bit of shuffling here. There we are. So now on to question 30. So the number of hours for which light bulbs will work before failing can be modeled by the random variable x with cumulative distribution function, that piecewise function there, f of x. So Jane sells light bulbs and promises that they will work for longer than exactly 99% of all light bulbs. Find how long, according to Jane's promise, a light bulb bought from her should work, and give your answer in hours rounded to 2 decimal places. Okay, well, since they've already given us the cumulative distribution function, and the big key here is that this is a capital F of x, right? So we know that we don't actually need to end up doing any integration here. What we can simply say is that 0.99 is equal to 1 minus e to the minus 0.01x. Okay, so 0.99, because that's how long these light bulbs are going to be lasting for, 99% longer than anything else. And now all we need to do is start solving for x. And so to do that, I'll probably just plus the e to both sides and then minus 0.99 from both sides. So we can say, therefore, e to the minus 0.01x equals 0.01. Okay, so now taking the natural log of both sides, what do we get? We get that minus 0.01x equals the natural log of 0.01. And there we are. So now we can say, therefore, x equals the natural log of 0.01 divided by minus 0.01. And so that will equal about 460.52 hours. And there we are. So that's question 30. So that one's actually pretty straightforward, especially in comparison to question 29, which we've just done now. Okay, so now on to question 31. I think we can afford ourselves a little bit more space here. So by considering the equation of the tangent to y equals x squared minus 1 at the point a squared minus 1, find the equation of the two tangents to y equals x squared minus 1, which pass through the point 3, negative 8. So the first thing, and I think it's the most important thing to notice about this, is that the point 3, negative 8 does not occur on this parabola, okay? A lot of people would try and start looking at the point on the parabola that will pass through this point and then start looking at your different gradients and getting a little bit confused about what might be going on. But what we need to note first is that this point is not going to be on this parabola, okay? So the first place I think we should start though is simply by writing down our equation. So y equals x squared minus 1 and writing down our first derivative since we know we'll be looking at the equation of the tangent. So y prime equals 2x, pretty straightforward. And that is obviously going to be our gradient. So what can we say now? Well, according to our coordinates over here, right, of a and a squared minus 1, well, it must satisfy those 2 points, and then we know that it must have the gradient of 2x, and it must therefore also end up passing through the point 3 minus 8. So what we can do now is we can use our point gradient formula, so y minus y1 equals m outside of x minus x1, and start substituting in some values here. So now it's going to look like y minus, so y1, so our y1 value is now a squared minus 1 equals, and so 2x, well that's just our m value, okay? And we know that our m value, 2x, is going to be 2 times a. So we'll put 2a out the front there. And now x minus a. And there we are. So now let's work out what this will become. So now we'll get y minus a squared minus 1. That will just simply be y minus a squared plus 1 equals 2ax minus 2a squared. Okay, so what we get now is that, I might just come over to the right hand side now, is that y equals to negative a squared, because we will add that a squared to both sides, plus 2ax minus 1. Okay, and so now what we do know, again, is that it must pass through the point 3 minus 8. So now what we can do is we can substitute into our x and y values here, the points 3 and negative 8. So doing that, we get negative 8 equals minus a squared plus 2 times a times x, which is now 3, so I might just write plus 6a minus 1. Okay, so now what we end up with is just a pretty straightforward quadratic. So a squared minus 6x minus 7 equals 0. And so what we can say then is that this factorizes out to simply be a minus 7 in bracket multiplied by a plus 1 all equal to 0. So we can say therefore a equals negative 1 and positive 7. So fantastic. So now that we've done that, we've figured out what our a must be. So now what we need to do is return back to the equation for y equals, and then that lovely quadratic term over here. And so doing that with our different values of a, let's see what we get. So we might say y1 for equation 1 is now going to be equal to minus 7 squared plus 2 times 7 times x minus 1. And so that will equal to minus 50 plus 14x. And there we go. So that's equation 1. That's our first equation, tangent to this parabola here that will pass through the point 3 minus 8. So now let's determine our y2. So y2 is now going to be using the a value of a equals negative 1. And so let's see what we get now. So that's going to be equal to minus times minus 1 squared plus 2 times minus 1 x minus 1. And that's going to give us simply minus 2x minus 2. And there we are. So that's our equation 1, and that's our equation 2. And so that is question 31 sorted. So a little bit of a tricky problem. The main key here was to identify that you're just going to be working with the general sort of variables of a and then a squared minus 1 for your x and y coordinates initially. Okay, so now moving on to question 32. So, in a particular city, the heights of adult females and the heights of adult males are each normally distributed. Information relating to two females from that city is given in Table 1. So we know that their height, their gender, and the percentage of females in this city shorter than this person. The means and the standard deviations of adult females and males in centimeters are given in Table 2. Okay, so again, we have our mean, standard deviation, and the gender. So a selected male is taller than 84% of the population of adult males in this city. So by first labeling the normal distribution curve below with the heights of the two females given in Table 1, calculate the height of the selected male in centimeters, correct to 2 decimal places. Okay, so first things first, we need to recognize that that's our mean in this peak position here. So then that means this will be the mean minus the standard deviation, mean plus standard deviation, mean plus 2 standard deviations, and so on and so forth. So now looking at this table here, well, we find that this is directly corresponding to what we know about the empirical rule, right? So that I believe 68% of data is within 1 standard deviation of the mean, and then that 95% of all data is within 2 standard deviations of the mean. So what that now means is that essentially, if you're taller than 16% of people, then that means that you must lie down here, 1 standard deviation less than the mean. So it's going to be 160.6. And now if you're taller than 97.5% of people, that means you'll be 2 standard deviations above. So now this becomes 175. Okay, so now what we need to do is let's quickly determine what our sigma value is, so our standard deviation. So we can say that 175 minus 160.6 is going to be equal to 3 times the standard deviation, because we've jumped up 1, 2, 3 times. Okay, so now simplifying that and working it out, we get that sigma is going to be equal to 4.8 centimeters. And we also know that since mu, the mean, is 1 standard deviation greater than this value here of 160.6, we can therefore say that mu is going to be equal to 165.4 centimeters. Okay, so now that we know that, we also know that for the males, we have a mean value of 1.05 mu and a standard deviation of 1.1 sigma. So if this male is to be taller than 84% of all men, then that means that they're exactly 1 standard deviation above. And so what we can say now is that the height of the male, so I might write it like this, h sub m, is now going to be equal to 1.05 mu, so the mean, plus, and because it's only 1 standard deviation above, it now just ends up being plus 1.1 sigma. And so working that out, we get a value of 178.95 centimeters. And there we are. Now moving on to question 33. So people are given a maximum of 6 hours to complete a puzzle. The time spent on the puzzle in hours can be modeled using the continuous random variable x, which has a probability density function of ax over x squared plus 4 for x between 0 and 6. So the graph of the probability density function is shown below. The graph has a local maximum. Okay, so the first things first is that we need to show that a equals 2 over the natural log of 10. Okay, so first things first, well, we know that we have this probability density function there, and we know that the entire area underneath a probability density function is going to be equal to 1. So what we can say right off the bat is that 1 is going to be equal to the integral of f of x dx. Okay, fantastic, and we know our limits as well, since it's just going to be from 0 to 6. Okay, so now 1 equals, so now the integral of f of x, so the integral of ax over x squared plus 4, well, we can take that power of a out the front, so that will become a, and we know that this can essentially be rewritten now as the natural log of x squared plus 4. However, to do that, we need to take a factor of a half out the front. Okay, and so now we take those from the limits 0 to 6, and let's see what we get. So that will now become a on 2 times by, so now subbing in that 6, we'll have 6 squared, so 36 plus 4, so the natural log of 40, and then minus, so now the natural log of 0 squared plus 4, so that's just the natural log of 4. Okay, so what do we know according to our log laws? We can then simplify that to just be the natural log of 40 over 4. And so that means that now we can rewrite this as a on 2, natural log of 10. So all we need to do now is solve for a, and we see that, well, therefore, a equals, so multiply both sides by 2 and divide both sides by the natural log of 10. We get that a is going to be equal to 2 over the natural log of 10. And there we go. So that is exactly as required in part A. So part B, show that the mode of x is 2 hours. So for something like this, well, what we need to do is we just simply need to solve to find that maximum point there, since we know that's where the mode must occur. So how do we find the maximum point on this function? Well, pretty simply, all we need to do is we need to differentiate this function and then find the minimum. Okay, so now to find f prime of x, and so I might just quickly write that that was part A up there, and this is part B. So f prime of x is now going to be given by, so what have we got? We've got ax over x squared plus 4, but we know that a is going to be equal to 2 over the natural log of 2. However, we can essentially end up ignoring that because we know that we are going to just end up using our quotient rule here. So our quotient rule is going to be u prime v minus uv prime over v squared. And so what that will become now is, so u prime, that will just become a times by v, which is x squared plus 4. Now minus ax times by v prime, which is now just going to be 2x, all over x squared plus 4 all squared equals 0. Okay, so what we have now is we have our first derivative of f of x, and so what we need to do now is simply solve that. So we can end up saying, just by getting rid of that bottom denominator, we'll multiply both sides by x squared plus 4 all to the power of 2. So now what we end up with is a outside of x squared plus 4 minus 2x squared equals 0. Just after quickly simplifying this left-hand side here. Okay, so what that now means is that we can simplify and solve. So that must mean now that 4 minus x squared equals 0. So therefore, x squared must equal to 4. And we know, therefore, x equals 2, since we're only going to be taking a positive value of x here. So we can say, therefore, the mode is at 2 hours. So therefore, mode equals 2. And there we are, since the maximum is at 2. So now for part C, show that the probability of x less than 2 is equal to the logarithm of base 10, 2. Okay, so for this one, all we need to do now is simply integrate this from 0 to 2. And well, luckily we've already worked out our integral formula. So we know that the integral will end up becoming a over 2 times by now the natural log of x squared plus 4. And now we're taking the limits of, what are we taking the limits from? 0 to 2. And so now that becomes a on 2 times by the natural logarithm of 8 minus the natural logarithm of 4. Okay. And so again, simplifying that and solving that, we get that that is now going to be equal to a over 2 times the natural log of, so 8 over 4 is going to be 2. Okay, but what else do we know? We also know that a can be rewritten as the value of 2 over the natural log of 10. So doing that now, we get that the 2's will cancel out, and that this can now be rewritten as the natural log of 10. And then this essentially just looks like our change of base formula. So the natural log of 2 over the natural log of 10 can be rewritten as log base 10 of 2. And there we go. So that's part C, as required. All right, now part D. The intelligence quotient, IQ, scores of people are normally distributed with a mean of 100 and a standard deviation of 15. So it has been observed that the puzzle is generally completed more quickly by people with a high IQ. So it is known that 80% of people with an IQ greater than 130 can complete the puzzle in less than 2 hours. A person chosen at random can complete the puzzle in less than 2 hours. What is the probability that this person has an IQ greater than 130? And give your answer correct 3 decimal places. Okay, so first thing we're looking for essentially is the probability of the IQ being 130 or greater than 130. And so that can then be rewritten, I suppose, as the probability of the IQ minus 100 over 15 greater than 130 minus 100 over 15. Just that way we're now looking at our z-scores, and that's just going to give us the probability that z is greater than 2. Okay, so that's all we're working with now, so just our simple z-score. And so we know that the probability of being greater than a z-score of 2 is simply going to be equal to 2.5%. Okay, and that's again just coming from our empirical rule. Okay, so now what we need to look for is the probability given that they solve it in less than 2 hours. What is now the probability that their IQ is greater than 130? So what that looks like now is that probability of IQ greater than 130 given that t is less than 2. Well, that's going to be equal to the probability of the IQ being greater than 130, and now intersect that with the time to complete being less than 2 hours, since that's also been given to us, and now divide that through by the probability that the time to complete is less than 2 hours. And so we actually have values for all of these different terms. So the probability of the IQ being greater than 130, well, we've already worked that out to be 2.5%. I might just get a little bit more space. So we know that that will now equal to 2.5%. Now times by, so the probability for the time to complete being less than 2 hours, well, that'll end up giving us a value of 80%. And then now the value where t is less than 2. So there's a reason that this now comes up. So that's exactly what we worked out in part C. We worked out the area underneath this probability density function from 0 to 2. And what that ended up being was a logarithm base 10 of 2. And so that's exactly what we can put there on our denominator now. So log base 10, 2. And so now putting that into your calculator, all you get is 0.0664, and now it does say correct to 3 decimal places, so it's just going to end up being 0.066. And there we are. That is our final answer for part D. Okay, so now moving on to question 34. So the last question on the 2021 HSC Advanced paper. So a discrete random variable has a probability distribution as shown in the table where n is a finite positive integer. So we need to show that the expectation value is equal to n times by 2r minus 1. Okay, so let's quickly look at what's going on here. So our x value goes up, so r squared, r cubed, all the way up to r to the n. And then the probability starts at r to the n, then goes down by 1 each time until we get to just r by itself. So what we can say now is, well, we clearly have a sum going on here, right? So this is actually just going to be the sum of a geometric progression. When we go r plus r squared plus r cubed plus dot dot dot, that is simply a GP, okay? And so what we can consider now is, well, what's our rate? Our common ratio is now just going to be r, and our initial starting value is also going to be r. So now if I look for the sum of these values, so according to our formula, the sum is equal to a bracket r to the n minus 1 all over r minus 1. Okay, fantastic. So let's see. So the sum of the probability must be equal to 1. So what I can say now, therefore, is that 1 must be equal to r outside of r to the n minus 1 all over r minus 1. So this is all just coming back from our geometric progression formulas, which I believe are on the formula sheet. So, okay, now what are we working with? It's a little bit confusing to see why we even care about this, so let's quickly multiply both sides by r minus 1. And so now we end up with r minus 1 equals, and let's take that r inside. Now r to the n plus 1 minus r. Okay, so what we can do is go ahead and add r to both sides, and then we end up with 2r minus 1 equals r to the n plus 1. Okay, so that's useful, but why is that useful? So it's good to have gotten that value, but now let's refer back to our exponential, sorry, not our exponential, our expectation value equation up here. So 2r minus 1, aha, so that must be something important. So now if we were to consider the sort of generic expectation value equation, well, what does that look like? That looks like this. So the expectation value of x is going to be equal to the sum of the different values of x times by the probability that x is equal to that x value there. Okay, and so what that looks like now is r times by, well, r to the n for the first one, plus, now it's going to be r squared times by r to the n minus 1, plus dot dot dot, so on and so forth, until eventually we get r to the n times by r. Okay, and so what does this look like now? Well, every term we see is actually just going to be r to the n plus 1. But how many terms do we have? Well, we've got 1, 2, 3, 4, all the way up until n terms. So now we can rewrite that as n times r to the n plus 1. And now using the fact that r to the n plus 1 is equal to 2r minus 1, we can now say, therefore, the expectation value is going to be equal to n times by 2r minus 1. And there we are. So that completes our 2021 HSC Advanced paper. We have shown our expectation value there. So depending if you've gone through the entire exam and watched the entire video, or if you just looked at certain questions to get a little bit of help, I hope you have enjoyed the video. And if you would like to leave a like and subscribe, I do appreciate that. And all the best in your studies. Cheers.